All right, today is an exciting day because we are starting Unit 2. And we're starting with the whole theme of the unit is we are solving linear equations. So the first target 2A, is all about solving linear equations with variables on one side. And we're sticking mainly to one-step and two-step equations today. Obviously, we'll move on a little bit later in the unit, but today we're starting basic. So first and foremost, all I want you to do is I want you to try these two Ignite problems. And what I want you to do is I want you to tell me what specifically is happening to x. Is x being multiplied by -2? Is it being divided by 4? Tell me just in words, what is happening to the variables in those two equations? So pause your video right now and take a sec and see it and describe it to me, one sentence max each. All right, for number one, we're saying what's specifically happening to x. We're not looking at what's on the other side of the equals sign. So for right now, I really am kind of ignoring the equals 10 part. Now, if there's a number in front of the variable and there's no sign in between, it's not being added. That's the common mistake that I'll see. If there's ever no sign in there, that just means it's being multiplied. So x right now is currently being multiplied by -5. In number two, x, a different thing is happening. Now again, I don't care about what's happening on the other side of the equation, and we'll talk about what makes an equation shortly. But right now, we're saying x is being, now here's the main difference. If that addition sign is written, it tells you what's happening. X is being added to -12. And this skill is going to be pretty big in what we start to do next, because we're going to start off with just on all unit one. You'll probably look back and notice that we didn't use the word equation all the time. That's because being an equation means something pretty specific. An equation specifically has an equal sign in it, whereas an expression doesn't. So you'll notice that there's, when we look at the directions coming up, it's not going to say simplify the expression. So when you are working with expressions, you can only simplify, combine like terms, distribute, anything along those lines. But when we go ahead and in a second, we're going to solve linear equations, you can only do that when you have an equal sign. Because when we talk about solving something, solving just basically it means tell me what the variable is equal to. Now, a lot of times you'll hear me use another phrase. I'll say get the variable alone. If we're going to get the variable alone, we have to have ways of doing that. And that's where what we call the properties of equality come into play. Now, we don't always use that phrase, but the idea is that you have to be able to undo things in order to kind of work your way backwards, which is essentially what solving is. Now, you'll remember that every single operation in math, almost every single operation, has kind of like an undo button. In addition, if you want to undo adding something by another number, we use subtraction. Called an inverse. The inverse of addition is subtraction. Vice versa, the inverse of subtraction is addition. Hopefully you can, how about this? Right now, take a second, see if you can remember what the opposite of multiplication is. Hopefully in your head you were thinking that division is the opposite of multiplication, which means the inverse of division is multiplication. Now, there's a special term that we use when we undo multiplying by a fraction. Now, you can always use the inverse of multiplication. You can divide by that fraction. You can also do something called multiply by the reciprocal. And we'll talk about this one in just a moment, so kind of hold off on that one. But now we're going to get into the main body of this, and we're going to actually talk about what does it mean to solve. Now, there is one specific thing that is going to be so important when we solve equations. And that is whatever you do to one side, you must do to the other. Because an equation, think of it kind of like a scale. You have to keep both sides balanced. So if you add 7 to one side of the equation, that means you have to add 7 to the other. You can't add 7 to one side because then it's not going to be balanced anymore. So let's just start off with some simple one steps. And one step just basically means it's going to take one inverse operation to get the variable alone, because that's what the directions are asking us to do. They say solve, which means at the end of the day, like on number 1, your job is to tell me, well, what does y equal? Now, obviously, some of these one steps, some of you can probably do these in your head. I am going to look for the work on this. Even though it seems simple and it seems basic, these are going to be so important to what we're going to be doing later on, where you might not be able to know right off the bat. So I need to be able to see what you are doing. So for this one, right now, let's read it. It says we have y minus 10 equals 20. Now, that equal sign is kind of like the center, treat it kind of like the center of the scale. So what you do on one side of that equal sign, you have to do to the other, which means like if I wanted to add 7 to both sides, I could. Now you don't have to write this, but if I add 7 to this side and add 7 to this side, I could do that. We would add our like terms. Negative 10 plus 7 is going to be negative 3. 20 plus 7 is going to be 27. And you've created what's called an equivalent equation. Now here's the problem though, and that is that did that step actually tell you what y is equal to? Well, the answer to that is no. We don't know what y is equal to because we still have this minus 3 here. So when we go about solving, a lot of times there's going to be specific steps that we're going to look for. And usually it's going to involve looking at what's actually in the equation. Now, kind of like we did in the Ignite and at the top, we always want to focus on the side that actually has the variable. So I'm going to ignore the equals 20 for a minute, but right now, y is being subtracted by 10. So here's the great thing about equations. If I want to undo this piece, if I don't want to be subtracting 10, well, there's an easy way to move that negative 10 away. And that is to use the opposite of subtraction. Instead of subtracting 10, what we do is we add 10. And you're going to notice negative 10 plus 10 is 0. Now, you could put y plus 0. Anytime there's a 0, a lot of times, for the most part, we won't write it. But what happens is that essentially cancels out. And all we're going to be left with is the variable on the left-hand side. And that's what you're looking for in solving one steps. You're looking to make that piece either equal to 0 or, I'll explain it in a little bit, but 1, and we'll get there. But adding and subtracting is nice. All you have to do is either do the opposite of it and use the same number. Now, we did not follow the golden rule. Whatever you do to one side, you must do to the other. So we have to make sure if I add 10 to the left side, I also have to add 10 to the right side. Ooh, that was super messy, sorry. All right, and we add 20 plus 10 ends up being 30. Now, with equations, the cool thing about solving equations is that you can always know if your answer is right. If I plug it back in for the variable, it should actually make it true. So let's think about where we were at. The original was y minus 10 equals 20. So let's check it out. Let's try actually plugging in our answer for y. So let's say 30 minus 10 equals 20. Is that actually true? Yeah, totally. Because what is 30 minus 10? And does 20 equal 20? Yes, it totally does, which means that y equals 30 is our correct answer. Now, I realize some of you might have been able to look at that and say, well, what number minus 10 equals 20? And some of you might have been able to get 30 all on your own, which means that's awesome that you can recognize that. I'm still going to look for this work, though. I need to see what you're doing to both sides to undo the operation. And I know that seems kind of trivial today, but like I said, the problems that we're going to work with are going to get harder pretty fast. So I really want to be able to see what you're doing to both sides and if that step is correct. So this one, even though they're switched, I'm still taking the variable and I'm adding 5. So to undo that adding 5, we're going to subtract 5. But we have to follow the golden rule. If I subtract 5 to the left side, I also have to subtract 5 from the right side. Now we combine all like terms. Here, 5 minus 5, this turns out to be 0. That goes away. T, which means we're all going to be left with a T. By the way, guys, I do a cursive T because my T's look like plus signs. My normal T's look like this. So I don't do that. So this is a cursive T in case you were wondering. But then we say, okay, well, on the other side, well, what's 14 minus 5? Well, 14 minus 5 is 9. Now, before moving on, let's check our answer. We're going to have 5 plus whatever we're thinking T is, which we're saying is 9. And the question is, woo, does that equal 14? Well, 5 plus 9, is that 14? Yes, it totally is. And does 14 equal 14? Yep. That means this is your correct answer. Now, do you have to check your answer every time? No. But it is a good way to kind of look through and say, well, is my answer correct? Like if you're having any doubts, you can always check to see if your answer is right. Now, here's where it's a little bit different. Here, I have x plus -4. Now, I do get this question asked a lot. A lot of students ask me, they're like, Ms. Hardy, can I write it so that the variable is first? If you want to, yes. Because technically where we're at x plus -4. Now, you could recognize the fact that whenever we're adding a negative, essentially what our equation is x minus 4, which means we're going to use the inverse operation, addition. Now, you don't have to write it like this, though. If you're going to look at it from the original equation, if I'm adding a -4, we always really do the opposite of whatever sign is in front of the number that we're looking to get rid of. So here, if I have x plus -4, in terms of what do I do to both sides, I'm going to add 4. And either way, you're going to get the correct answer. Here, if I add -4 plus 4 is 0, that cancels. And we're just left with on this side an x. On the left-hand side, we have -12 plus 4, which ends up being -8. And you could always do a quick check too. If I take -8 plus -4, do I get -12? Yes, you totally do, which means x equals -8. Now, could you write it both? Could you switch the variable and the number around? Of course you can. You can write x equals -8 if you want to. I'll accept it both ways. Whichever way you're more comfortable with writing, either one is fantastic. Okay. So here's what I want you guys to do. I want you guys to give 4, 5, and 6 your best shot. I want to see what you can come up with, and we will go over these in a moment. All right, check your answers. Hopefully, now I'll talk through some of these. So like 4, in this case, if we look at what's happening to the variable is being invisibly multiplied by 4. So on number 4, hopefully your first step was you divided both sides by 4. 4 divided by 4 ends up canceling, and 84 divided by 4 ends up being 21. So final answer for number 4, we get z equals 21. Now number 5, well, this is a new operation we haven't seen, but here in my original step, we had b divided by -7. Now, if I'm dividing by -7, the opposite of division is multiplication. So both sides, what we do is we multiply by both sides by -7. Now here what happens when I do -7 divided by -7, you actually get 1. And ideally, technically what we're getting though is technically we have a 1b. If you want to write the 1, you can. A lot of times when it comes to equations, we won't write that. So when it comes to like 4 and 5, when we have multiplication and or division and we use the inverse of that, we don't look to we cancel out the number that's in front, but when you use multiplication or division by any number, you can never make it 0. The smallest you can make it is 1, and that actually is okay. Because when we do, like on number 4, when I do 4 divided by 4, it doesn't go to 0. Technically, it goes to 1. But at the end of the day, I want to know what 1z is equal to. I want to know what one of my variables is. So when it comes to multiplication and division, those you're not necessarily looking to make it 0. You're looking to cancel it out. But in multiplication and division world, it makes 1 instead of 0. So like, for example, in number 6, yeah, this one looks odd, but again, we look at the same thing. The variable, well, what's happening to it? Right now we're multiplying m by -4. Well, what's the opposite of multiplication? We divide. -4 divided by -4 turns out to be a +1, which technically in front of all of our variables, it's always a 1m. Again, we don't really write that, but if I divide the right side by -4, I have to divide the left side by -4, which looks odd. If I take 0 divided by -4, if you want to do that in your calculator and you're not sure, 0 divided by -4 is just 0. And actually that makes sense. If you wanted to check your answer, you're really just saying, well, what number times -4 gives me 0? Well, if I try 1, we get -4 equals 0. And that is totally not true. -4 is not equal to 0. The number that when you plug in, the only number that when you multiply makes 0 is 0. So if I take -4 times 0, I actually get 0. And that is totally true, which means this is definitely my answer. Okay. Now, when it comes to two-step, here's where we're going to follow some not different rules, but we have to start adding it in order. With one-step equations, it's kind of nice. Like those, there's only one thing to undo, so we just undo it. Two-step equations, we always kind of follow a specific kind of order in terms of how we undo things. So first and foremost, first rule of thumb is if there are any like terms, we always combine them. All right, so first step is always to combine like terms, if there are any. Sometimes there aren't, and that's okay. We just always check this first. Step number 2 is we always undo something pretty specific first. We undo addition and subtraction first. We're going to talk about a little more why tomorrow. And like I said, we'll get there. But for right now, hopefully just trust me. We always undo addition and subtraction first. And then if there's any multiplication or division in the problem, then we undo that. Ooh, wow, that was all backwards. Then we undo any multiplication and division. So we always are going to follow these steps in this order when solving. When we get to some more complicated ones, there's another step that we do kind of before all of those. So let's talk about number 7. So first thing I would say is, okay, are there any like terms that I can combine? Well, not really, at least not on the same side. So when we say combine like terms, we really mean on the same side. And here we don't have any on the same side. So then we move to step number 2, which is undoing addition or subtraction. And we have that. Technically I'm multiplying x by 3 and I'm adding 7 to that right now. So just the simple fact that I'm adding 7 means that that's the first thing I'm going to undo. I'm going to subtract 7 from both sides. Now, this case 7 minus 7, this ends up being 0 and canceling out. And we're just left with 3x on the left side. Now on the right side, we still have to actually calculate that. We have to say, okay, well, what is 19 minus 7? Well, 19 minus 7 is 12. But we're not done because the goal is solve, right? And solve means tell me what 1x is equal to. I want to know what one variable, what is going to be the correct answer that when I plug it in for x, it makes this equation true. And this is exactly why I always say show your work, because this problem isn't as easy to just look at the main equation, not do any work, and be able to tell what x is. What number, when I multiply by 3 and add 7, gives me 19? Well, for me, that's not easy for me to see. Even if it's easy for you, again, I'm going to ask, I have to see this work, because I don't know that you know how to do this. So the only way I can tell you that if you're doing it right or wrong is if you show me the work. But now that we've done step number 2, we undid that subtraction. Now we move on to step number 3, which is undoing any multiplication or division. And we have that. We are right now multiplying x by 3. So the last thing I have to do then is divide by 3. 3 divided by 3 cancels out. Technically, it leaves us a 1x. Again, I don't usually write the 1 in case you guys know. But then we simplify the right-hand side. 12 divided by 3 is 4. And there's our final answer. Now, again, if you weren't sure, you can plug it in. Plug in 4 back in for x, and let's see what it actually equals. Well, 3 times 4 is 12, and 12 plus 7 is 19. Does that equal 19? Yeah, that means this is our correct answer. Okay. So what I want you guys to do now, I want you to pause your video, and I want you to try examples 8 and 9 on your own. All right, answer to number 8 is up. We have, in this case, your first step should have been remember, combined like terms, but this one doesn't have any. So then we move to step 2, which is undoing any addition or subtraction. Since we were adding, and I'll use a different color. Since we were adding 5 to that side, to the left side, your first step should have been to subtract 5 from both sides. And then we were multiplying a by -4. So the next step is going to be dividing both sides by -4, and we should have got our final answer of 6. All right, yay. If you got 6, fantastic job, go you. Now number 9 was a little bit different. In this one, we actually have step number 1. We have like terms. If I have 4 A's here and I have 3 A's here, remember the variable doesn't change, we just add the numbers in front. We have 7 total A's in this case. So once you combine those like terms, then actually there isn't any more addition or subtraction. It's really just your basic one step from here. Here, and if there's nothing between that A and that 7, we're going to divide by 7 on both sides. And here's where you're going to start to notice something. If you take 64 divided by 7, it actually doesn't end up being a nice number. Now, if you weren't sure, I'm going to show you, remember, how you can tell using your calculator. So remember, if you want to get fractions, you would take alpha y equals. Now, actually, I'm going to show you a different way, because most of you probably wouldn't have used the fraction. Most of you probably would have just typed in 64, and then you would have divided it by 7. But here's the problem. You get this. Now, rule of thumb in all of algebra is if we don't start the problem with any decimals, that means we can't end the problem with any decimals. That doesn't mean you can't have a fraction. It just means that this is not the number that we're going to use. So the simplest way to convert this, now you could do this one of 2 ways. You can either convert this back to a fraction, and I will add this to the document that I have going in Schoology. But if you hit the math button, which is right below the green alpha button, these top 2 options, it says fraction and decimal, these kind of are ways to kind of toggle between the 2. So for example, ours is a decimal. If I want to write our answer as a fraction, if you click, you can either click, because 1 is already highlighted, you would choose the one that we want. So we want number 1 fract. Because all that means for us, it means it's going to convert our answer to a fraction. You don't actually have to do anything from that main screen. You literally just hit math 1, and then nothing happens. So it's kind of anticlimactic here. But if you go down below and actually now hit enter again, it converts it back to a fraction. And basically what this means for us is it means 64 divided by 7, 64 over 7. It just means it doesn't reduce anymore. But that means that that is actually my final answer. We are going to deal with the occasional problem where we don't get the nicest answer. And this is the perfect case. A equals 64 over 7, which is kind of gross. I get it. But if I were to plug that back in, you're going to notice that it actually still works. If I take 4 times 64 over 7 plus 3 times 64 over 7, actually it gives you 64. So if you want to try that in your calculator, go for it. But the you try nows at the end, these we're going to go over in class tomorrow. So if you want to get a head start on trying these, go for it. But these we're going to go over in class, okay? If you do want to pause your video, I am going to write in the answers so you can kind of check your work if you do decide to do them, but you do not have to, okay? All right, there are the answers. Again, if you want to try some of these and see if you're doing okay with these, fabulous. But we are going to go over these in class. If you have any questions, as always, you guys know what to do. Just email Miss Hardy or meet her in digital office hours.